Hi guys, today we're going to talk about section 5.7, roots and zeros. This is actually the very last section of this unit, so yay, we're getting past chapter 5. So here's the first thing we need to talk about. It's the fundamental theorem of algebra, and basically all it tells me is that depending on what my degree is, if I have some degree, say my degree is n, then that would also mean that it's going to have n number of roots, including the repeated roots. So basically, what I'm telling you is that your degree, remember degree is your highest power, is going to equal how many roots you have. So for example, in this question, the degree is 3, and it's going to have 3 roots. Again, degree 4 roots. Degree is 5, it has 5 roots, and so on. On this first example, what we're going to do is solve it and state the number and type of roots. So in order to solve this, I'm thinking, okay, it's a quadratic trinomial. What two numbers add up to 6 but multiply to 9? That's going to give me 3 and 3. So, or I could say x plus 3 squared, of course. When I'm solving, I set it equal to 0. So if I have x plus 3 set equal to 0, when I solve it, I'm going to get negative 3. So state the number and type of roots. We do technically have 2 roots. It just so happens that both of the roots are x equals negative 3. So we'd call it a double root. You can ignore that. I was trying to make parentheses. A double root. And that is a real root. This would happen if this quadratic was at negative 3. Like the vertex was the solution. Something like that. Let's try another one. I'm going to solve this one. Anytime I start solving, I try to factor first. And I notice here that there's a GCF. So I'm going to factor out that GCF first. And then I would try to factor this. I'm thinking x squared plus 25, can I factor it? But as a matter of fact, I cannot factor it because there's nothing that adds up to b, which is 0, and multiplies to give me positive 25. So I'm going to start by setting these factors equal to 0. X equals 0. Nothing to really solve there, but x squared plus 25 equals 0. Let's work it out. Subtract 25 from both sides. And then this is kind of interesting. When I take the square root, recall what happens if I take the square root of a negative number. I'm going to have the square root of negative 1 and the square root of 25, which the square root of 25 is 5 and the square root of negative 1 is I. So my answer here would be positive or negative 5i. So from the beginning, it says state the number of roots. There are technically 3 roots. 3 roots. It just so happens that only one of them is real. That x equals 0 is the real one. And then there's 2 imaginary. Those being positive 5i and negative 5i. Next, we're going to talk about Descartes' rule of signs. And I know this looks very lengthy and complicated, but let me tell you the gist of it. So Descartes' rules of signs tells me how many positive real zeros I could have and how many negative real zeros I can have. But this is what you have to do. The number of positive real zeros, it's going to be the same as the number of changes in sign of the coefficients of the terms, if it's, or it can be less than that by an even number. I know that sounds kind of complicated, but I'll explain it a little bit more when we do an example. To find the number of negative real zeros, it's going to be like the same thing. You're looking for the number of changes in signs, but of p of negative x. So I'm going to plug in a negative x, and it can be less than that by an even number. So what I underlined is kind of the gist of it. That's probably the main thing I would write, unless you're fond of writing paragraphs. So let's try this example. State the possible number of positive real zeros, negative real zeros, and imaginary zeros. So based on Descartes' rule of signs, what I have to do is notice if my sign changes from positive to negative or negative to positive. So notice that x to the 6th is positive, and 3x to the 5th is also positive, so no change in sign there. Whereas this third term is actually negative, so that would be 1 change in signs right there. Again, still negative, so I didn't change. This changed it to positive, so that's another sign change. From there, it changed to negative. That's a sign change. And then from there, it changed positive. So there are 4 possible positive real zeros. So for positive, T-I-V-E. There are possibly 4 real zeros. But it could be less than that by an even number. So it could be 2 or it could be 0 real zeros, real positive zeros. What we have to look at next after that is the number of negative real zeros. For the negative real zeros, what we had to do is actually plug in negative x. So I'm going to plug f of negative x. So I'm going to just plug all these in. Negative x. Everywhere I see an x, I'm going to replace it with negative x. All right, now that I've replaced all the x's with a negative x, I'm going to just clean this up a little bit. I'm going to make sure to be careful that I write my signs as accurately as possible. So I would always want to make sure to do what's in the parentheses first. So a negative raised to the power of an even number, it's going to create a positive. A negative raised to the power of a odd number is going to create a negative. So just kind of keep that in mind as you go through this. So it's going to be negative 4x to the 4th. All right, now I need to count my number of sign changes. So going from positive to negative or negative to positive. So positive to negative, that would be 1. Negative to negative does not count. Negative to positive does count. And it looks like the rest of them are all positive. So I only have on my negatives, I have 2 sign changes for sure, or I can have less than that. So I can have 0 sign changes, because remember, we have to decrease it by 2. If you go back to the rule, it says we can have the same as the number of sign changes or less than this number by an even number. So I'm going to scroll down just a little bit, and I'm going to create a chart that kind of shows all of the various possibilities, because the other thing we have to consider is the number of imaginary zeros. So there's positive zeros, there's negative zeros, and there's imaginary zeros. So this is how I like to go through this. If I have 4 positive zeros, I want to first think about the total number of zeros that I could have on this, and the total would be 6, and I know that because my degree is 6. So I could have 4 positive zeros. Let me see, I'm going to put that in red. I could have 4 positive zeros because that's what we discovered. But with those 4 positive zeros, I could have either 2 negative zeros or 0 negative zeros. And I'm getting that from the information that we figured out already. And from there, I had to figure out how many imaginary zeros could I have. Well, going across, remember my total has to add up to 6. So if I have 4 positive and 2 negative, that leaves room for 0 imaginary numbers. If I have 4 positive and 0 negative, then that leaves room for 2 imaginary. And I know that because it has to add up to 6. Let's go with our possibility of 2 positives. If I have 2 positives, I still could have 2 negatives or 0 negatives. And I have to figure out how many imaginaries there would be. So 2 plus 2 is 4, but I need that total to be 6. So there's another 2 there. 2 plus 0 is 2, but I need that total to be 6. So there could be 4 imaginaries. Finally, if I have 0 positives, I could still have 2 negatives or 0 negatives. So I just have to figure out how many imaginary possibilities there are. So 0 plus 2 is 2. So that would leave room for 4 imaginary answers. And if I have 0 positive and 0 negative, that would leave room for 6 imaginary answers. Again, how did I decide what's in that imaginary column? because the total would have to equal to 6, because we discovered earlier that the number of the degree is equal to the number of roots that I have. Okay, let's try one more. I want you to take a second to pause the video and see if you can find out the number of positive real zeros and negative real zeros. Go ahead and pause now. So I went through and counted the number of sign changes, and I discovered that there were 2, but of course it could be 2 or 0 because that number could be decreased by 2. Let's try the negative. For the negatives, I worked it out and I discovered that there were 3 total sign changes. So I could have a total of 3 negative zeros, or that number could be less, but I had to decrease it by 2. So it could be 3 or 1. That's the only possibilities for negative, because I want to remember that I would have to decrease this number by 2. So the total of my degree is 5. So I know that there's 5 possible roots. So let's go ahead and create a chart that kind of shows all the various possibilities for the type of roots that I could have. So let's see. I have positive roots, negative roots, and imaginary roots. I like to start with a positive. If I have 2 positive roots, there's a possibility for me to have either 3 negative roots or 1 negative root. So let's figure out our imaginary. 2 plus 3 is 5, and my total is 5, so that leaves me 0 chance for imaginary roots. 2 plus 1 is 3, so that leaves me a chance for 2 possible imaginary roots. Now let's look at the scenario when I have 0 positive roots. 0 positive roots. There's still a possibility for me to have 3 negative roots or 1 negative root. And I just have to calculate my imaginary root. So 0 plus 3 is 3, plus 2 would give me that 5. And then 0 plus 1 is 1, and then 4 more would give me the imaginary. So this list kind of encompasses all the possible combinations of positive, negative, or imaginary roots. On this next slide, you'll notice that I put some practice questions for you. These are the same ones that are posted in Google Classroom. All right, thanks. Have a good day.